We had a question on our quiz a few minutes ago that asked us for the instantaneous velocity at, I think it was 2 seconds or something like that. It doesn't matter what it was. That was a fairly easy question because the graph looked like this. Position versus time graph that looked like this. We had already found the average velocity over this interval, and when we have a straight line, the average velocity over that interval is going to be exactly the same as the instantaneous velocity at any one given moment. So we know how to do this, right? We want to find the instantaneous velocity right here, get the slope of that line. That's going to be your instantaneous velocity anywhere along that line. But what if we have a question like this, where we want to find the instantaneous velocity? This was question number 4 on your worksheet the other day. You weren't asked to find the instantaneous velocity anywhere on this. Okay, but today I'm going to show you how to find it if you ever are asked to find the instantaneous velocity. What we really have to do is find the slope of a given moment in time, of a given point of that graph. And that's more of a challenge than you might think. Okay, let's say we want to find the velocity at 4 seconds right here. The temptation is to say, oh, look, d is about 1.75, t is 4, so the velocity is 1.75 divided by 4. That doesn't work. You can't use v equals d over t. You can't. Okay? Velocity is displacement over time, not position over time. So that equation just doesn't work in this situation. So how do we do it? Well, we're going to draw what we call a tangent line. A tangent line is a line that goes through only that one point and follows the curve. Now, I can't really do it with a ruler on the board here, so you're going to have to bear with me. I'm going to do it by hand. Okay, pretend I'm using a ruler and pretend the line that I'm about to draw is a nice, perfect straight line. Okay, you'll have a ruler. If you don't have one, I'll give you one in just a moment here so that you can draw a tangent line on yours. Here's what I want to do. Okay, here's a line that goes through only that point, but that doesn't follow the curve. Here's another one that goes through only that point, but it doesn't follow the curve. Here's another one that goes through only that one point, but it doesn't follow the curve. Here's one that follows that curve, but goes through a whole bunch of points there, right? See, some points before it, points after it. We want to, at least as close as possible, we want to cut through only that one point, but yet still follow the curve. We want it to look something like this. Does that make sense? That's a tangent line. Okay? You'll know if you've got a good tangent line because A, it has to follow the curve. Okay? The curve is sloping upwards like this. Okay? Your tangent line is going to be sloping upwards. B, you know that you don't want to touch any points before or after that one point. You want to go through only that one point, okay? No, not at all. You don't have to start the line at 0, 0. In fact, if it does go through 0, 0, you've either made a mistake or you've, how do I say? The odds are it won't. The odds are it won't. It's possible that it'll go through 0, 0, but it would be just fluke if it went through 0, 0, and that's not likely going to happen. Okay? So what do you do with it at this point? What do you do with that tangent line? Well, that was the easy part. You want to find the slope of the tangent line. You guys know how to find the slope, right? Pick 2 points on the line. Pick 2 points on the line. Rise. Let's say the rise in this case would be 3 over the run, which is going from 1 to 7 seconds, 6. The velocity at that moment in time would be 0.50 meters per second. Now, that doesn't count for later on. If I wanted to find the velocity at this moment in time, it's different because the tangent line hasn't been drawn for that moment in time. Draw a tangent line for that one moment in time, and then you're back to where we were in the last couple of days. Just find the slope of that tangent line or use delta d over delta t at that point. Got it? Okay, I'd like you to go worksheet number 4. Go to that last question on worksheet number 4. Do the same thing, not for 4 actually, do the same thing for 4 seconds. Okay, for that point at 4 seconds, and see if you get somewhere in the range of 0.5 meters per second. Once you're done that, and once I've checked that, then I'd like you to do the same thing at 7 seconds. Okay, find the instantaneous velocity at 7 seconds. If you need a ruler, I'll give you one, okay? All right, let's take a look at the next one that I asked you to do at 7 seconds. Okay, tangent line for this one, going to be a lot steeper. Okay, tell me if I have a good tangent line drawn. Pretend that I'm drawing a nice straight line. Pretend that I'm using a ruler. Okay, so don't judge me on that. Just tell me if this is a good tangent line if it was straight. Is that a good tangent line? Why not? Why is that not a good tangent line, Carrie? Yeah, it's got to really follow the curve, and this doesn't really follow the curve, right? It intersects that line. It doesn't really follow the curve, so that's not good enough. Okay, we don't want that one. That's going to give me too high of a velocity. What about this one? That cuts through only one data point, right? Is that a good one? That doesn't follow the curve either, right, Stephanie? Absolutely, absolutely. Yeah, we'll take a look at that in just 1 second here, Stephanie. It's a good question. Okay, that's not a good tangent line. Okay, what about this one? Is that a good one? It's better, isn't it? It follows the curve, but it doesn't really go through just one point. Okay, it's not real bad, but we want to make it a little bit steeper to avoid this. Okay, we got a line that's going through a whole bunch of different points there. We want to avoid that if possible. Let's try this one. Is that better? It's still actually not fantastic because I got a little bit there before the point where the line is touching the graph. Okay, it's much better though. Let's try one more and see if I can do a better job with this one. Is that better? That one's pretty good, right? That's pretty good. Okay, so now that we got a pretty good one, let's pick 2 points on that line. Doesn't matter where they are. Okay, let's go here and here. Ideally, 2 points that are far apart. Doesn't matter if they fall on 2 grid lines on the graph that are intersecting or not. Let's take the slope of that line now. Slope is the rise over the run. This one looks to be about 5.7. 5.7 minus 0. Okay, the rise is 5.7 minus 0, and the run is, what was that, about 3.5? 9 minus 3.5. So we get 5.7 over 5.5. What does that give me? About 1 point, I don't know. What is that? 1.03 meters per second. How many people got a number that was kind of close to that? 0.9, let's say 0.9 to 1.1, somewhere in that range. Okay. Who got a number that was like 1.2-ish, 0.8-ish? Who got a number that was quite a bit different than that? All right, thanks for your help. Raise your hands, guys. It doesn't matter. If you got it right, that's great. If you got it wrong, that's fine. Just raise your hands.